welcome. Today we'll be talking about security in Kubernetes. So I'm Mike Kaczorowski. I'm a product manager in security at Google, and I focus on containers.
And I'm Brandon Baker, tech lead for container and cloud security at Google.
And so the purpose of this talk is to talk about security. And earlier this year at KubeCon in Copenhagen, one of the messages in the keynotes was resoundingly clear: this year it's about security. Now that we're here in Seattle and it's becoming a reality, we're seeing that in the last couple of months. We've seen huge strides to improve security in Kubernetes. And so let's look back at what's actually changed. In this talk, we'll cover what's happened in 2018 in Kubernetes security, cool new features that are worth a second look, including isolation and software supply chain and hardening, and then what we hope to see in 2019. So let's jump in. Let's start with the worst of what happened in 2018. What's actually happened that's affected security in this space? Looking back at the year in threats, we haven't actually seen that many active attacks in the wild. It seems the industry is still just picking up in this regard as attackers learn about containers and Kubernetes and how they can best exploit these. In February, Tesla made the news for attackers finding and accessing their Kubernetes dashboard and using the cloud credentials that they gained to mine cryptocurrency. This was similar to something that happened in December of 2017 with Aviva. In May, Shopify had a researcher report a vulnerability in their cluster configuration. This was not exploited. In June, Weight Watchers had the exact same problem that Tesla had. It was found by a researcher, once again, and not exploited. And the same month, several container images were found on Docker Hub that had embedded malware for mining cryptocurrency. Anything that's happened more recently, unfortunately, we just don't know about yet. The NSA does. What's really interesting about all these attacks, you might notice, is that none of them explicitly attack containers or containerized workloads. Some do attack Kubernetes and Kubernetes configurations, but the end goal isn't even Kubernetes. It's something more interesting because that's not how an attacker can most easily make money. It's by mining cryptocurrency. Let's look at each of these a little bit more. So starting with Tesla and Weight Watchers, because what happened here is essentially the same thing. If you're not familiar with it, the Kubernetes dashboard is a web-based interface to interact with your Kubernetes deployment. It lets you see what your deployment is doing, look at the state of resources in your cluster, any errors that might have occurred, et cetera. Now, if you're not familiar with it, it's probably because you're using a cloud-hosted Kubernetes solution from a provider. They probably have their own dashboard, their own console that you're using, and that's why you haven't seen this before. So what are hackers doing with this dashboard? There are two main faux pas to avoid here. The first is having the dashboard be publicly accessible. So it's not necessarily bad that it's a public IP address, as long as you actually protect access to that. This prevents anyone from just going in and looking at your cluster, fiddling with your configurations, et cetera. But actually, when attackers are exploiting your dashboard, they probably don't even care about your application. And that's because there's something even more interesting, which is what's in the dashboard in terms of your secrets. If you're keeping sensitive credentials in your dashboard and using Kubernetes secrets, these might be exposed in the dashboard and left open to anyone who has access to that, including insiders at your company. Someone can get those credentials and exploit them, and that typically leads to abuse. This is exactly what happened to Aviva, Tesla, and Weight Watchers. In all of these cases, the teams had deployed their dashboard on the public web with no password protection and had privileged cloud account credentials in those dashboards. In all of these cases, hackers took these, or in some cases, researchers found these, logged in, and started mining cryptocurrency. This, sadly, isn't unusual. In fact, Lacework estimates that there are over 20,000 public dashboards, of which 300 are not password protected. For the next up, Shopify. Shopify has a bug bounty program set up for their infrastructure, including core technology such as the stores that they run, some of which runs on Google Kubernetes Engine. In May, they got a really terrifying bug report from a researcher claiming to have root access on all Shopify instances. So what happened? Well, the researcher from an arbitrary Shopify store was able to complete a server-side request forgery using Google Compute Engine metadata from a prior version of an API. And using that, they obtained the project name and instance name of where this particular Shopify cluster was running. With this information, the researcher could submit a request to the instance to obtain kube environment variables, including the kubelet cert and private key. They were able to use that to execute arbitrary commands in the cluster. Shopify did a really good job here. Within an hour of receiving the report, they disabled the vulnerable service and began wider remediation. There's a lot more detail about this specific research report. Check that out in a talk that's happening later this week on Thursday. You can hear about Shopify's rapid response and the $25,000 bug bounty that ensued. In June, Cromtech reported on various Docker Hub security issues, and in particular discovered that there were 17 images with malware embedded in them in Docker Hub, named things like Docker 123321, right? They were just play little images. and they contained malware that were used for cryptocurrency mining. Prometheus estimates that they were up online for about a year, pulled 5 million times, and mined a total of about $90,000 of Monero in that time period. In the grand scheme of things, that actually isn't that much cryptocurrency. For me, it's more of like an interesting study in like what an attacker could do and how little people verify these images and how much trust they just put into Docker Hub. If I were an attacker, I'd be far more interested in putting a backdoor into one of these popular images and seeing what happens. One of the really interesting things with this particular article is that people knew this was happening, and they were complaining about it on Twitter and on GitHub, but there was no one responsible for remediating this kind of attack, right? It wasn't an official image on Docker Hub, and so nobody did anything, and it wasn't addressed. So to kind of sum up the attacks that we're seeing, right? The real threat to containers running in production today is kind of boring, to be honest. From what we've seen so far, when attackers gain access to a cluster or cluster resources, it's not to take advantage of anything related to Kubernetes, it's just to get the underlying compute and mine cryptocurrency. And so what we're seeing is just these drive-by scanning attacks. I'm an attacker, I'm opportunistically scanning tons of stuff online. I don't care if it's a VM or a container, and I don't care if it's on-prem or in the cloud. I just want to be able to mine some cryptocurrency. This means that the best thing that you can do to protect your containers is to patch them. To patch your base image, your packages, your application code, everything. Now, inversely, what people are really scared of, but doesn't actually happen in practice, are container escapes. A common concern about containers is they don't provide a strong way to contain workloads. Users are hesitant about running multi-tenant environments, deploying 2 containers for different workloads on the same VM because they're worried about one workload affecting another. Though this is possible in test environments, this is not what we've seen in the wild, and if I had to guess, it's still a while away, at least from being public. That leads actually really well into the next topic for conversation, container isolation.
Right, thanks, Maya. So, when we think about these threats, we often focus on those external threats, right? So somebody coming outside and trying to DDoS an instance or exploit some network interface to compromise it, maybe extract some data that they shouldn't be able to extract out of some containerized workload, or maybe compromise the workload, but all they're going to do is just harvest some CPU resources and do some crypto mining in it. But now thinking ahead, we also need to be concerned about internal threats, right? Threats from the container workload back out. Right? If a containerized workload is compromised, what other kind of data does it have access to? If that containerized workload can be used as a foothold to try to compromise the operating system outside of that container, what can attackers get to, right? And so when we think about isolation, we think about these threats. While Maya mentioned we haven't really seen those kinds of escapes yet happening in the wild, we do know that it's a security threat that researchers are looking at, and it's also one that we take very seriously in our threat modeling at Google. And Maya gave the example around multi-tenancy, and I think there's definitely a direction and certainly a strong desire towards getting to a place where you could run multiple workloads, say on the same node, workloads from differing trust levels or workloads from different users. But then we have to also then present that against the challenge around containers not really being designed as a security containment mechanism from the very start. Right? Containers contain dependencies. Containers are great for deploying workloads to environments and moving them from environment to environment. Containers aren't exactly really the best thing to think about security because ultimately they just rely on operating system security, which has had its problems in the past. Okay? And when we're thinking through these use cases, like why would you ever want to think about multi-tenant kind of environments? Wouldn't we just want to use one node per customer or one node per security level? Well, I mean, there's certainly a lot of cases where you may be, for example, intentionally trying to look at something that's untrusted, using other tools that are trusted, maybe a security engineer doing malware research. Or you may be looking at taking a third-party application from upstream that you haven't reviewed the source code for, right? And so you're now imbuing a lot of trust in that thing and bringing it into an environment. But what kind of access does it have access to when you're running it? Maybe it's a project that's historically had problems with vulnerabilities, and you don't really just want to let it run wild in your environment. But yet maybe it does still provide some interesting or useful value. I think MPEG encoding is a canonical example to where it's useful, but also the code behind it has had a lot of bugs. Okay? So in each of these cases, you don't want the security of those things to affect the security of your other workloads. So thinking about this, is ultimately coming down to a notion of kind of trust and the relative trust within the workloads. And trust is a relative measure. It depends on where the code is coming from. It also depends on the kind of data that the workload is accessing. And the more sensitive data you process, the more you need to be able to trust the code that can access it. So when we look at the isolation features that exist in Kubernetes today, there's many. And they run the whole gamut around different containment areas or granularity within Kubernetes, right? From the container to the pod, namespaces around that, up to the node level, cluster level, project level overall. But these mechanisms as they provide may not be strong enough depending on the trust level of your workload, or may require you to fall back to a coarse granularity of isolation that isn't efficient to run. The other thing that this diagram really says to me too is that isolation in Kubernetes is very complex. There's a lot of things to manage, right? And like with any other security control, there's a lot that users are expected to get right to configure. And I think in that, there's also now an opportunity for us to think about as a community how we can help users simplify these configurations. We'll talk more about that later. So moving on to looking at 2018 and the last 12 months or so, there have been actually some really interesting developments around isolation, related to isolation for containers. 12 months ago, December at KubeCon in Austin, Kata containers was announced. And that was a project that combined Intel Clear containers and Hyper's RunV. The idea behind Kata is that you can build a really lightweight virtual machine and use that to contain workloads. And the sandbox environment has a really stripped down guest operating system that has less attack surface and less actions and less privilege. But the idea here is just sort of kind of running one pod, one collection, one sandbox per VM. And then you would run multiple VMs per node. And that works great if your nodes certainly are physical machines. If your nodes are themselves already a virtual machine, because you're using that for workload and scalability, or because you're running on the cloud and the cloud provider is running virtualization underneath, though that does mean you're not having to nest virtualization, a VM inside of a VM. And that brings with it some performance penalties and overhead. And then move forward to May of this year at KubeCon EU, Google publicly unveiled gVisor, Google's internal sandboxing technology. Google deploys over 4 billion containers a week internally, and the majority of untrusted code in those containers runs inside of gVisor at Google. What gVisor is it provides a strong isolation boundary by intercepting application system calls at the application layer, rather than sort of more traditional virtual machines, which is intercepting things at a lower machine level. And what that means is that we are able to take all the system call interactions that a workload would normally have with an operating system and encapsulate and emulate that behavior, and then further sandbox it. At Google, we have a security guiding principle that we have 2 strong security boundaries between untrusted code and the rest of Google, other workloads and data, and gVisor helps us get that. Okay. Then moving on to June of this year, IBM introduced Nabla. Nabla uses a unikernel, which is a library OS, kind of similar to gVisor in some ways. It's a little more streamlined, and it still relies on kernel or operating system isolation. What Nabla is just doing is reducing the number of system calls that need to get passed through to the underlying operating system, but doesn't completely eliminate them, different than gVisor that way. And then most recently in November, Amazon unveiled Firecracker, which is another lightweight virtual machine isolation technology, somewhat similar to Kata, but instead of using the QEMU virtual machine manager as Kata does, it uses a custom, lighter weight, sort of more container native VMM. The other difference, Firecracker is more focused on sort of hosting and providers, where Kata is kind of a bring your own sandbox type model. So where are we going with all these different technologies, right? I mean, this is ultimately getting us to this idea of actually getting native sandboxing in Kubernetes, right? Actually getting to containing containers from a security point of view. And I think this is one of the most exciting developments that we've seen in 2018. Now, where are we focused around the layer of isolation? Well, we've kind of settled in around the pod being the right granularity to think about sandboxing, to think about isolation. And that means that you could have multiple containers per pod, but that each of those containers inside of the pod will be inside the same sandbox. So they should be relatively similar trust levels or users or whatever, however you think about dividing security. We'd like to be able to say that there are two strong security boundaries now between that pod and the rest of the system. Okay. And so ultimately, getting towards, now how do you run these? How do you actually run a containerized sandbox? Well, good news. There's effort underway in the Kubernetes community to extend isolation and properties of pods by tying them directly to sandboxes. And that takes me to the RuntimeClass. This is a new feature that's been introduced as an alpha feature in Kubernetes 1.12. The initial implementation provides a runtime selection API, including a way to select a sandbox technology that you want to use for an individual pod. It's implemented as a custom resource definition, CRD, and it's defined as part of the pod specification. So the runtime class gives users the ability to select, as I mentioned, what runtime should be used with each pod. And why that's exposing that level of detail is so that users could select sandbox runtimes, say gVisor in some instances, Kata or Nabla and others, depending on their security, their isolation needs, depending on the compatibility of the workload with the underlying sandbox technology. Right? If you want to know more information about RuntimeClass, Tim Allclair, one of the contributors to the RuntimeClass, gave a talk earlier today, and I definitely recommend taking a look at that. And with that, I'm going to hand it back to Maya to talk about another area of concern in 2018.
Thanks, Brandon. The next topic, software supply chain, has also been a hot topic on many developers' minds this year. Ultimately, a software supply chain, what we mean by that is any code that ends up running in production and the mechanisms that build, package, and distribute that code. It's about making sure that what you're running in production is actually meant to be there, that you built it, that you verified it, and that you authorized it to run. This is because while developers and security teams are awakening to how they can use containers to improve their security models, hackers are also waking up and saying, hey, if I insert something a little bit earlier in that chain, I can get into lots of companies' workloads really easily. So what do we actually mean by a software supply chain here? Good security practices for a container software supply chain have a couple different components. So starting off with the base image, you control your base image and choose minimal images that let you limit the surface of attack. Any external images that you want to use, you can pull, retag, and then copy into your local container image registry. The code, you write your code, scan it for potential security issues as well as dependencies. And ideally, you can perform more complex security reviews and assessments if you have the time. Build, you build the image yourself. Ideally, this is a hermetic, reproducible build. The cutting edge here is something called rootless builds, which are builders where root is not required to actually build the image. Application image, you scan the image for vulnerabilities. This is about decoupling your image into the base image and the layers that sit on top of it, and verifying each of those for vulnerabilities. You'll end up scanning OS components, binaries, jars, tarballs, everything. And you can also scan your images for misconfigurations or if they don't meet certain policy requirements that you might have. And deploy. At deployment time, you can enforce specific requirements such that your images did in fact come out of your pipeline. You can also enforce runtime requirements like that your image runs with seccomp. When something changes, like when a new vulnerability is discovered or in a package that you're using, you just go back to an earlier stage in the supply chain and you rebuild and redeploy the image to fix the issue. There have been a lot of efforts in the last year to address these, and the tools aren't necessarily new this year in 2018, but the threat to the supply chain is new, which is why we've been focusing on this. So one of the more interesting attacks we saw this year was the one we mentioned earlier around Docker Hub, and we're likely to see more of this type of attack in the future. There were images on Docker Hub with malware that they were embedded with malware that mined cryptocurrency. How could you have avoided a similar attack in your environment? You could not pull images from public repositories directly, instead adding them to your local registry once you've verified them and they've met certain needs that you have. You could scan your images for vulnerabilities, malware, or other security issues, and only deploy the images that you've scanned that are in your repository and that you trust. Now, I can enforce lots of other things like this at deployment time, anything that's happened previously in your supply chain. So that scan that I just mentioned, but that it was built by my builder, maybe that it was built in the last 30 days, that QA, test, legal, whoever signed off on it, that it was only deployed in a particular geography, et cetera. You can imagine all kinds of policies you might want to enforce at deployment time. So say I only want to focus on those first items, that I only want to deploy images that have been scanned for vulnerabilities, and let's be reasonable, that don't have any high unpatched vulnerabilities. Note that I didn't say no vulnerabilities, as there might be some for which patches don't exist, and so that's the reality of you running that workload. And I also specified high vulnerabilities, as those are the ones I'm most worried about in my environment. Kubernetes has the concept of an admission controller for a plugin, which is a piece of code that intercepts requests to the Kubernetes API server and can make admission decisions. It basically decides you shall or shall not pass. This is pretty cool because it's a functionality that enables enforcement of what actually gets deployed. It's a single choke point for everything that ends up in your environment. So what do I actually need in my supply chain to be able to enforce the requirements I said earlier? First, I need a way to scan for vulnerabilities and store information about those scans. And second, I need a way to enforce, like with a Kubernetes admission controller, that images that haven't been scanned aren't deployed. There are 2 open source projects in this space that were announced last December and have gained popular momentum now, Grafeus and Kritis. So Grafeus is an open source project to audit and govern the software supply chain, and you can use it to track information like versioning and vulnerabilities. It's a little bit more, it's not much more than a key value store plus verification of that store. Grafeus stores metadata about artifacts, like images, and information about those artifacts, like vulnerabilities. You don't need to use only one source of metadata either. You can have multiple providers. So vulnerability scanners, for example, can each write their own results. There are many providers, metadata providers like JFrog, Red Hat CoreOS, IBM, Black Duck, Twistlock, and Aqua. As your software supply chain grows or evolves, you can just add new metadata types and new providers. Then the real benefit that you have is that all your metadata is in one place about your images. It lets you answer interesting information, like if they're currently affected by any recently discovered vulnerabilities. Kritis is the sister project to Grafeus. Kritis is a Kubernetes admission controller that can block builds based on policy. It has a policy engine to test assertions before deploying into Kubernetes. For example, your build provenance or the vulnerability scans that we just ran. Cluster admins manually test images that are verified and okay to use. Then Kritis will only allow the deployment of attested images. Kritis also integrates with attestation metadata APIs, so it can speak the same language as Grafeus. So where do those fit into our chain? Well, if you guessed, one does one and the other one does the other one, you're good. Grafeus stores metadata for image. This specifically includes metadata for vulnerabilities, for scan results, and an attestation for those results, the signature. Note that Grafeus isn't a vulnerability scanner. It's just a consistent way of storing scan results that you might get from third-party scanners. And then Kritis then enforces the deployment of an image based on the attestation information in Grafeus. There's a reference implementation of this exact flow online if you check out the link at the bottom of the page there. Note that there are a lot of other open source projects in the space that can help, like Portiris, Notary, and Intoto. You can check out another talk from KubeCon China, the state of your supply chain, to get more info. And then if you're running on Google Cloud, for Grafeus and Kritis, we have hosted solutions with a very similar flow. Earlier this year, Google Cloud introduced 2 products here, GCR vulnerability scanning and binary authorization. Container registry vulnerability scanning is both a scanner plus the metadata store. It scans Debian, Ubuntu, and Alpine base images and their packages for known vulnerabilities from the CVSS database. Once turned on, it scans images each time an image is added to the registry, plus anytime there's an update to the vulnerability database. Binary authorization is the admission controller for Kubernetes engine. It allows enforcement of what's deployed in your environment by signature verification. You can set this up for any kind of attestation, a vulnerability scanner like we talked about earlier, but also your build pipeline, image tests, whatever you might have. Taken together, this starts to tell a pretty good story for how you can secure the software supply chain. But I suspect we'll see this area remain vulnerable and a key point of interest in the year to come. The last point I want to mention on supply chain is why you should care so much. It's that running containerized microservices with a supply chain that you actually secure properly leads to a fundamentally different security model for containers than for virtual machines. So containers are meant to be short-lived and frequently redeployed. Rather than pushing a single line of code change, you're rebuilding and redeploying a whole container, the whole image. If you have other processes that can take place passively, like patching your OS, for example, you don't need to have any downtime. You can actually just be constantly doing this to your image in your image repository. You don't have to have a Sunday 2 a.m. maintenance window. You just roll out that new image the next time you roll out, like you would roll out software. Containers are also meant to be immutable, so they don't change once they're deployed. You have content addressability, which means that you know what's in your environment. So next time, even if when you scan your image, it doesn't have any vulnerabilities, and then you deploy it, but a new vulnerability is discovered, you don't have to go back and you don't have to scan your live environment. You can go scan your deployment history and see if you're affected by something that's been newly discovered. Since you're not changing single lines of code, but whole containers, you have that single choke point for everything that gets deployed in your infrastructure, and you can enforce governance. So taking those together, that tells a really strong story as to why you want to have an immutable pipeline, immutable containers with a pipeline that you have vulnerability scanning in, that you can enforce your policies in. All of that together is a very strong story for security.
Right, thank you. So now we've looked back at 2018. Now what do we see going forward? And that brings us to the last set of topics, right? So hardening and some of our predictions for 2019. So I'd say, despite the fact that we haven't seen many breakouts of containers this year, there were certainly quite a few vulnerabilities discovered that affected Kubernetes, or really the whole containerized ecosystem. For an infrastructure service like Kubernetes, you have to think about the whole stack and patch issues all the way from really hardware up to the kernel, to the operating system, the VMs you're running, Kubernetes itself. It's a lot to keep up with. We had a really exciting year, I'd say, because we've had issues in most all of these layers this year. Okay? And really on top of that, then you have to think about patching the applications, the workloads you run on top of it. I will note that we have a fantastic Kubernetes security team, and if ever you find vulnerabilities or hear about them, please responsibly report them, because that team is responsible for developing the fix, making it available out to Kubernetes distributors, and ultimately helping everyone patch their workloads. Okay. And again, we're kind of back to this theme again around the simplest thing you can do to protect your cluster from attacks is to patch your cluster and keep it up to date with the latest version of Kubernetes. If you're running on the Google Cloud, Google's Kubernetes engine pushes out new versions weekly, which contain security patches. GKE will manage the master for you, including patching the master in case of security vulnerabilities. For nodes, if you're running on container-optimized OS, COS, on GKE, it can patch them for you using node auto upgrade. And you can also put maintenance windows around to control when that is done. So it's really kind of a theme around helping to automate and seamlessly patch the infrastructure underneath workloads. But patching on its own is not enough. Right? There are many places where good defaults are missing in Kubernetes, and where you're going to need to do some hardening of your own on clusters. Earlier this year, we shared a guide on Kubernetes security, which provided a roadmap to help manage security, kind of depending on where your maturity of the cluster is. And it covered a wide variety of areas, from cluster configuration, and good best practices, things like using RBAC and TLS and configuring namespaces. Good hygiene, say like on the network, making sure you didn't have open network ports or open master dashboards. Dealing with known attacks and getting those patches out there and keeping up with CVEs for the workloads you're running and the code that they inherit. And then also thinking about limiting the damage in case you did have a compromise, about reducing privileges and about protecting secrets, and about using things like service meshes like Istio to take authentication out of applications and into a place that can help broker authentication from instance to instance. For Google's Kubernetes engine, we further published another hardening guide that covers the main elements to address there, kind of based on the difference of what's done by default and what's not. And there's a link to that at the end of the talk as well. So what you'll notice, though, is that previous list is entirely too long. Right? There's just too much that we as a community are asking average users of Kubernetes to take on for themselves to get security right. And there's too many chances to misconfigure. There's too many chances to get things wrong. So we think that the #1 prediction for container security going forward into 2019 is going to be around hardening and hardening by default. I think this will be a big focus, right, which is making Kubernetes more opinionated about security and providing better defaults to protect any and everyone using Kubernetes platform. And I think this is something that we as security engineers need to do. I don't think we're doing enough there yet, and it's a responsibility that we take pretty seriously, right? And so that's going to be in kind of several major areas. That's going to be around simpler configurations, about getting templating, about setting better defaults, removing permissions, things like open dashboards, perhaps getting a default seccomp profile into Kubernetes. There's a lot of wish list items, but I think that there's appetite for that in 2019. The other thing is I think we'll see a convergence in isolation technologies. Right? There's many options right now. Go back to that slide from Kata to gVisor to Nabla to Firecracker. You've got a lot of options. And I think that we might see some convergence around that. And some options may stand out versus others. Maybe some become the leader around compatibility, some for performance, some for strength of security isolation. Okay. And then the last thing I was going to mention here is, but ultimately I think it depends on kind of what's going to work for users, what's going to best work for them. So another 2019 prediction is going to be, probably see more attacks, more container-specific attacks. As more developers are using containers and containers are running more and more interesting data is being processed through them, attackers will get more interested in the containers and the data themselves and the access they provide beyond just access to a CPU to do some cryptocurrency mining. So we expect to see some of the first attacks developed in 2019, specifically targeting containers, breaking out of containers, going after Kubernetes that way. I think we'll also continue to see supply chain attacks. As Maya mentioned, that's just too open and too ripe of an attack path right now, and depends on too many things to get right, including the security of the internet, which we're likely to see, I think, more of those kinds of attacks too. I think on the positive side, I think we'll be seeing more and more vendors in this space for security for containers, and maybe specifically around actually detecting attacks against containers and as the container is compromised. And if we're lucky, maybe we'll even see some of that get open sourced. So with that, it's a wrap. Thank you very much. I hope you enjoyed our 2018 retrospective and look at 2019. Well, this year. We do have open mics along the walkways there if anyone has questions.
Hi there.
Yeah.
So it seems to me like there's sort of an underlying assumption with the isolation discussion about VMs being sort of a impenetrable isolation technology, and I just can't. I remember in my mind back in 2009, 2010, hearing about privilege escalation issues with Zen and VMware, and then those sort of cooled off. So I just wonder if there's sort of not just a maturation cycle we're in.
Yeah, I think that's a fine question. I think really the best I would say is that virtual machines are the best isolation technology we have today, but it's not perfect, right? It's still that there's a lot of concerns there. What I will say is a lot of investment and attention from the security research community has gone into looking at VMs and VM escapes, patching and fixing hypervisors. Google, we invested a lot in KVM and security for KVM. So we have growing confidence in that over time. But the flip side is then the virtual machines are really heavyweight, very expensive, very difficult to run.
Can I respond to that also?
Yes.
Just one comment there on that one.
Sure.
For the claim that VMs are the best, that's actually debatable. In the Nabla paper, they count kernel functions that get called by VMs versus called by Nabla containers, and the Nabla containers exercise less of the kernel than a VM.
Yeah, I think it depends on the VM technology we're talking about and how it's structured. There's a layering question to that conversation as well, which is how many independent layers of software are getting exposed to untrusted workloads? And if you had a bug in one, how many does that carry over? So I think this as a community is absolutely a conversation that we should continue having. I'm happy to talk more about that. Yeah, over here.
So I got a question. So of course, isolation, immutability, sandboxing, right? All these are great techniques that we get sort of for free when we go down this route of containers, Kubernetes. But if you look, I've been studying breaches over the last 3 or 4 years in the enterprise. They're not escape breaches.
Right.
They're struts to in a 30-year-old Java application that basically they hit a Tomcat container and they kill chain their way in. And I get how you can mitigate some of that, but are we being a little myopic here by focusing on this kind of perimeter escape kernel vulnerability versus what most of the banks are, where the real dangers are, which are like our Java. And one more point, I know I'm going on, but like in your world and a lot of Greenfield world, you have a nice scoping on your dependencies, right? Like you don't go out and use all the libraries from Apache in general. But a bank, like if you look at the dependency mapping of their core applications, 90 to 95% of everything written is open source. And then the dependency mapping, like you look at the struts to Jakarta breach that hit Equifax.
Yeah.
I mean, the dependency list will scare the hell out of you, right? And they don't have tight control of that loop. So am I making sense? That's my kind of comment question.
For sure, yeah, and I think there's two parts to that. I'm gonna take one part real quick, and Maya, I think, has a lot to say on this too. For that dependency side, there's also the identification of where that dependency is coming from, what the security stance of it is. And also, can we use things like sandboxing to then take that system that has a lot of dependencies and sandbox it off such that if there is a problem in one of the 58 different things that it imports, that it doesn't affect the rest of the environment around it. But I think to your point around isolation is an ideal versus...
There only really is a port on, on a Tomcat container that then hits a default Jenkins in another container, right? Like that's the norm of business. There's certain ports we have to open up. And we can't isolate those, and we can't predict all the combinations.
Yeah.
And that's how the really bad guys get us.
Yeah, and I think there's also another opportunity there for using this sort of service mesh idea, getting things like Istio between these instances, so you're not just talking network port to network port and IP whitelist to IP whitelist. Absolutely, yeah.
Yeah, container escapes are not a thing that we're obviously seeing in the wild, or like we know it could happen, but that's not a threat yet. It's these really boring attacks, like we were just saying. It's like, oh, you didn't patch, you have WordPress with a standard password. Like, it's very, very boring what we're seeing. I'm actually surprised, and I'll have a controversial opinion, how much people have cared about isolation this year, because the only people who should really care are the cloud providers or people running multi-tenant workloads at scale, right? So if you're not running your own Kubernetes cluster and running a multi-tenant workload where you're taking arbitrary container images, arbitrary ML models, arbitrary something from your customers, this shouldn't be a concern for you, right? You're already running in a single tenant model. So this isolation is obviously a very, very important problem. It's not something that everyone needs to care about, which is kind of interesting. Yeah.
Hey, thanks for the talk. One of your slides mentioned restricting access to kubectl. Can you tell me what do you mean by that?
Yeah, I meant restricting access to who can talk to the control plane. So on GCP, we have a feature called Master Authorized Networks that lets you restrict the set of IP addresses that can talk to the control plane. It's that I've seen customers build bastions that then they put in front of kube control that they don't want someone to be able to talk to. If you think about how powerful kube control really is at the end of the day, you might not want the average developer in your organization to talk to it. And likewise, if an average attacker can somehow access it if they touch some part of your organization, that can be quite damaging.
Okay.
So to kind of actually dovetail on the previous topic, there was an attack vector on Postgres earlier this year called the Scarlett Johansson attack, which you may have remembered about, which people actually front-doored into Postgres and then broke out of Postgres to get information on the file system, such as secrets or things like that. So I think my question more on the lines of, is there any investigation or interest in how people are trying to prevent access into seeing other APIs or trying to detect that via like audit trails or things like that? Because that was a very big surface area footprint from a front door perspective that even in these areas of container breakouts, thinking about it in the reverse direction of going through the front door to get into a container instead. Yeah, kind of the application security and sort of the application security scans and pen testing, I think is an area that that we have some interest in and have been looking at, but I think that's probably an area that's not particularly well covered yet right now, I would say, both in the industry and open source. So I think that's definitely an area of interest for sure. The other part of that too is kind of the questions around how do you lock down access from one workload to another workload, and what are those interactions that they have between themselves? And then how do you keep that from being turned into a way for an attacker to propagate from point to point? And that's getting back to some of those secure defaults, to templating, the other things where I think we also need to have more attention, more investment.
The other concern I have is if you're running two workloads in the same cluster even that have very different security models. If you look at something like you just mentioned logging, like audit logs are non-namespaced. So how do you, if you can get access to that, then you can see what the other thing was doing. but you can't necessarily access the other workload, right? And so there's actually a really great blog post by Tim Allclair that lays out what isolation you get at every level of Kubernetes. So that was the image from earlier, what running in a separate pod actually gets you, or running in a separate namespace actually gets you. Users ask me all the time, they're like, hey, should I run each workload in its own namespace? And I'm like, what's your threat model? Like in some cases that makes a ton of sense, and in some cases you actually want separate clusters, and in some cases you want different projects or whatever it happens to be. Yeah.
So after we containerize the service can run weeks and weeks. How can we guarantee that the service is short-lived and also immutable as well?
I think the question is, how can we guarantee the service is immutable? There isn't a
Right.
great way to do that right now.
Yeah, I mean, that's one of the fundamental challenges around like code attestation and verifying the signature of code. If like that's the verification that it's the right code at the time it was started, but the moment it starts to take any sort of interaction with the outside world, the provenance, like the correctness of that code is potentially now at risk because it could have had a buffer overflow in it, could have other vulnerabilities, and now the code is no longer really the code that was deployed there.
That means we still need to have some scannings on the running instance, right?
Correct.
I think in your previous slide you mentioned there's no need to scan the live instance.
Yeah, you could either scan what's running in production. Another method that I've seen proposed, although not implemented, was Docker was proposing doing something called reverse uptime, which is, what if you just never had anything that was older than a certain date running in your environment? So if your cluster became a month old, just kill it and start again from scratch. And the idea being, everything in your environment is less than a certain amount old. It's been patched in that time period, and that if it's deviated, it's only deviated for that amount. That doesn't solve your problem exactly, but that could help limit that.
Right. Yeah. Think like Chaos Monkey for security, right? Where you're shooting things in the head regularly just to make sure that you're actually running the latest, correct patched version. It's not been compromised. Everything else.
Got it. All right. Cool. Thanks.
I haven't seen anyone do this. It's just an idea.
So I have a question regarding the software supply chains. So far I have seen that it is happened before the container actually deploy. So what happened after the container deploy, I think also related to the live scanning. But the other thing is like, let's say, if it's run an images or software library that has a CVE just recently discovered, how is this? Do you have any plan to have this lifetime enforcement that will say, okay, we invalidate this image and it will trigger down a whole chance of invalidating in the container that's running on this image, for example?
Yeah, the only thing you could do would be to scan. So the benefit there that containers provide you, if they are immutable, right? If they're not changing in production, is that you don't have to scan your live production environment. You can scan your images, in your deployment history, in your image repository, and see what's been affected. As far as I know, there's no easy tool that then lets you go kill that thing. You still have to kind of debug that yourself, find where it is, and kill it. But the idea being you could easily find out if you're affected. That's typically like if anyone who has a CISO that they have to report to, a new vuln comes out and they say, am I affected? That's the first question they have, just how bad is it really? Give me a report in the next 24 hours and go from there.
Yeah, but that kind of scenarios happen for, let's say, developers or something when we kind of actually control and knows the library that we call. In a lot of other settings, when we just try to run a lot of third-party libraries and so on, we don't know actually how much library we have. And it would just like automatically scan and database coming from Aqua or coming from Chislop, and they say, hey, this has a vulnerability, and we actually don't know, the developer don't know what is the vulnerability, it's just in the databases. And so it's need kind of automation triggering it down. This is, I think, one of the most important things for the enterprises as well.
Yeah, thank you.
Over on the side, please. Go
ahead. I have a question regarding the admission control. You mentioned about KTs. I've seen that there are a lot of products in the market like Twistlock, Aquasec. They scan images. Is there any push in the industry to have a common standard so that we can directly use those and use directly in the admission control instead of going multiple routes?
I haven't seen, so the point being, yes, I've seen a lot of admission controllers across a lot of different vendors. The two open source ones that I know of are Porteris and Kritis. There might be more, apologies if I don't know about them. I haven't seen anyone try to push towards a common standard there. I guess the standard is that they're all Kubernetes admission controllers. So that is a standard configuration, a standard way of doing this.
Okay.
But there isn't a common API or anything like that as far as I've seen.
Thank you.
So maybe this is more of just a comment to add to the discussion rather than a question, but one of the things that scares me is I mean, with the recent vulnerability, you wouldn't see any logs for what was actually done in the cluster, right? Or maybe more important, and an attack that I think will increase over the next couple of years is people getting phished, and then, developer accidentally exposes credentials, and now we have some attacker kubectl execing into the cluster, and I mean, there are tons of vendors here that will give you every solution to be able to find that and to log even the most recent vulnerability. But I think it would be awesome if in the community we could also see more ability to have better insight into what's going on.
For sure.
I guess Falco may, for example, provide some of that.
Yeah. I think we're definitely in agreement with that. Yes.
Hi, so my question is basically around user namespaces, and I was wondering if you guys have any particular experience with using them or not using them. I know they haven't quite landed in, in main Kubernetes, but you see them more at a container runtime and container runtime interface level, but they haven't really been exposed all the way up through. And it's really looking 2018 onwards, 2019 onwards. We see a lot of the software supply chain, how you build your images, and we are getting to the point where, okay, we're not building and having the container run as root, or the process inside the container run as root. But a lot of older images are already built such that they're run as root. If you pull the average image off Docker Hub, most likely it's going to be running as root. And especially if you look at some of the existing tool chains that we have, like everyone loves to use Docker build, by default it's going to run as root, right? So I'm just curious if you guys have any experience in terms of user namespace mapping.
I mean, I'll look at Tim over here. I think the answer is yes, but I actually want Tim to answer this one because he's been working on that. So.
Yeah, I forgot to ask him at the earlier.
Yeah.
Yeah, so it's definitely something we want to enable. We're talking about it in SigNode. Right now, the approach is to have a sort of single user namespace for the entire node, or a single user namespace mapping. So the root user is going to be the same across all containers, but not the same as the root user on the actual host. And the reason for that is because if you're using volumes that live longer than the pods, then getting the permissions right so that the pod, when it reschedules, can still access that volume is pretty complicated.
Yeah, and I think the other part of that is, I think user namespaces are a great way to sort of manage or reduce privileges and reduce process-to-process sort of crossover problems. It's not itself, at least you don't consider it as a strong security isolation boundary, right? Because it's still just Linux kernel boundary. But certainly from managing permissions and managing privileges, yeah, super, super useful.
Thank you.
Hi, I'm on a small team, and are there tools available that will make managing, building my own supply chain easier? I have a whole bunch of different technology that we're using, but short of just me monitoring GitHub pages to know when they change their Docker file, when they make improvements to it, is there anything that makes that easier, that workflow?
Not now that I know of. Yeah.
I
think people don't realize how bad the supply chain problem is going to get. Like the NPM thing from a couple weeks ago is for me, it's like Pearl Harbor, like the canary in the coal mine. It's going to get really bad. So I think we're likely to see lots of stuff, but there's nothing yet that I know that's really good.
I mean, I guess really it's kind of really, at least in the cloud provider point of view, it's kind of focusing on curated images, Google Container Repository, GCR, right?
I mean, scan anything that you're going to use at the image level, but to your point, if there's a dependency that I have that's in a package that has dependency all the way down, you don't know what you're running at the end of the day.
Yeah. Okay, thanks.
Sorry, that's a really depressing answer.
I mean, it is what it is, right?
I think the other thing that I'll say about this is I get a lot of kind of enterprise customers that tell me oh, I can't run this thing that I haven't verified, and I'm like, then you can run nothing. Good luck.
or again, we get the sandbox pod really there, and it's easier to take those things you're not quite sure where they came from, and you can fire that off, but you fire it off in some sort of sandbox, And then the potential, if it actually is bad or comes from somewhere strange or whatever, the potential for damage is now constrained or eliminated from the rest of everything else you're running.
Yeah, I think the best thing you can do is create, this sounds, again, we're gonna say the same thing, be really good at patch management. If you're patching your things on a regular basis and you're constantly rebuilding, redeploying, the amount of time that you'll be affected is gonna be very limited, right? Because it's not about, you know, some person making a comment on some blog post somewhere that's gonna let you know what's happening. It's gonna be, just run the latest patch version. And the reality is, even those scans, those drive-bys that we were talking about earlier, it's not people, you know, using the latest vuln that was dropped last week or anything like that. It's people looking at Apache struts. It's people looking at things that have been around for years that have been unpatched. So the advantage of moving to containers is that you can be constantly patching, and you can do that without having significant downtime. And so you should.
Great, I think we're
Great.
good on questions. Thank you very much.
Thanks all.